السلام عليكم ورحمة الله وبركاته. My dear students, in course Operating Agricultural Engineering Units, this will be our first lecture. It will be about some engineering basics we need in our course. Problem solving techniques. We face problems every day. Some of these problems involving our relationship between each others, and other problem require a mathematical solution. Of course, we are here talking about those problems requires a mathematical solution. How to solve them? To solve a problem, there are some basic techniques. First of all, we need to read the problem carefully and visualize it. Then we need to sketch the problem if we can. Then the need. We have to know what we need from this problem or what the problem need. So we need to write down the needs and making a list of the unknowns. Know, list everything else we know from the problem. How, the equation or the formula relevant to the needed and the known, the need, what we need and what we know. If we have if we know formulas or equation, we write it down. Then solve this equation to find the unknown, calculate the values, and of course we have to check the units. As we said before, or as we mentioned before, every number followed by its unit. So when we calculate the values of the unknowns, we need to check the units in each calculation. These are the basic problem solving technique: read, sketch, need, know, how, solve, calculate. For example, to illustrate the diagramming and sketch, if we have a problem like how many posts are needed to build a fence 100-meter long with posts 10-meter apart. So if we think in this problem without sketching the problem, we may say 100 meters over 10 meters, so we will need 10 posts. We will divide 100 over 10, and we would say we need 10 posts to build this fence. But after we sketch the problem, we will find that we have the 100-meter here. It's laser pen. This is 100-meter long, and let's put the fence, the first fence, the first post, second, third, a space between post and the other post will be 10, so 10, 20, 30, and we will find that we need 11 posts, not just 10, as we solve it without sketching. This example to show us how important sketching or diagramming the problem. In how stage we mention equations or formula. So are there any difference between equations and formula? Yes, equation. We can derive equation for any problem. But formula is a fixed or a constant equation. Like the area of circle area equal pi d square over 4 or pi r square. So this is a formula, but equation we can derive it as we said in the previous question. Maybe we say the 100 meter over 10 meter. This equation, this is equation, not a formula. So if we have a problem saying how much wire needed to build a single wire fence around the rectangular field. So we have a rectangular field and we want to build a fence, a rectangular field, and we need to build a fence around this field. We need to build a fence right here around this field, measuring 450 long, 350 meter wide. So this 400, the blue is not 450, and as we said, every number must or should followed by its unit, and this 350. The perimeter or the long, how much the wire needed. So wire needed equal, we can say 450 and 450 to multiplied by 450 plus, and here 350 and here 350. Of course here meter. So it will be 1060 meter long. Meter, we just, if we have a razor here, just the unit, the number and its unit, the number, الألوان so this we can call it equation. This equation unit cancellation. We have two rules here. The first rule is the units associated with numbers follow the same mathematical rule as number. So if we have here 2 feet times 2 feet, we will multiply 2 times 2. Then, as we saying, the units follow the same mathematical rules as number. So feet will be multiplied by feet also. So times 2 times 2 would be 4, or 2 square. Feet times feet, feet square. If we have here 3 tons over 4 hours times 4 hours over 5 days. The second rule would say the units of the numbers behave according to the rules of fraction. So we can cancel a unit as we can cancel number. So here the 4 can be cancelled with 4. 4 would be cancelled with 4. The units here, hour and hour. They behave according to the rules of fraction, so they also can be cancelled. We can cancel hour over hour. Then 3 over 5 ton per day. 3 over 5, 6 over 10, 0.6 ton per day. When we talk about units and we have to write a unit after the number or the value. For example, if we have equation here, 40 meter plus 100 centimeter. If we don't write down the units after the value, we might solve this problem in wrong way. Someone would say 51. But here, after this, we count, multiply, or subtract different units for the same quantity. So the length here, meter is a length unit and centimeter is a length unit. We can't add them to each other before we convert one to another. So we can convert meter to centimeter or convert centimeter to meter. As we mentioned before, how we can do this by conversion factor. We would write down that from the conversion factor table, 1 meter equal 100 centimeter. Then we build our conversion factor, and as we said before, it's a fraction and it should equal unity or equal 1. We can put the 1 meter up on and 100 centimeter down, or vice versa. We can put the 100 centimeter up and 1 meter down. So which one we have to use? If we want to cancel the meter, for example 40 meter, and we want to cancel the meter, as we said before, to cancel the meter must or should be down. So 1 meter will be down to cancel meter with meter, and 100 centimeter will be up plus the 11 centimeter. So we have here 4,000, 40 times 100 plus 11, so it will be 4,011 centimeter. This, if we want to cancel the meter, so this number B will be right. If we want to cancel the centimeter here and convert it to a meter, so if we want to solve this problem using the meter unit, so we have to cancel the centimeter. So we write down 40 and every number followed by its unit, meter, plus 11 centimeter, and we want to cancel centimeter. To cancel this centimeter, centimeter have to be down, and the meter will be up. 1 meter equal 100 centimeter. To cancel centimeter with centimeter, so 11 times 1 over 100, 0.11. So we have here 40 meter plus 0.11 meter. It will be like for 0.11 meter. So A also is right. So the right answer here would be A or B. In the previous problem, we add a unit to another unit, meter plus meter, and the result was meter. What about multiplying units? Multiplying units. If we want to calculate area, a rectangular area, for example, 3 meters times 5 meter, the length and the width, the area would be length time width. It would be 3 meter time 5 meter. And as we said before, the units followed the same mathematical rule as their values. So we will multiply 3 times 5, 15. We should multiply meter time meter. Meter time meter would be like x times x, x square, meter times meter, meter square. But the addition or subtraction would be just meter. Oh, what about our problem here? 1.5 meter times 3.0 kilograms. Let's see. Here we have a different units. Can we multiply them? Yes, because they are not units for the same quantity. We can't multiply meter times centimeter. We can't do that. We have to convert one to another first. We can't multiply meter time inch or time mile or time yard. We need to multiply the same unit. If we talk about same quantity, length, area, volume, for mass مثلا kilogram can't be multiplied by grams, libra, ounce, ton, and so on. We have to convert one to another. But if we have a different quantity like force, Newton, times length by meter, we can multiply them. Newton times meter, Newton meter. Newton meter equal joule. So here we can multiply kilogram time meter. So the answer would be 3 times 1.5 would be 4.5. We can write the meter first, then the kilograms, or kilograms first times meter. So the first one will be right. The second, some kind of tricky. Here we have grams times kilometer. The kilo, the symbol K for kilo in SI unit system mean 1000 or 10 power 3, 1000 or 10 power 3. So the kilometer is 1000 meter, kilogram 1000 gram, and so on. So if we convert the kilogram to grams, it would be like, we want to cancel the kilogram, so it would be down 1 kilogram equal 1000 grams for 1500 meter grams. Here by kilometer. So we want to convert meter to kilometer, the conversion factor. We want to cancel the meter, so the meter would be down and the kilometer will be up. 1 kilometer times 1000 meter. The meter would be cancelled with meter, and 1000 here was 3, so it would be 4.5 gram kilometer. So B is also right. Then A or B will be the right answer. Here we want to add 1.5 meter, subtract minus 3 kilogram meter over second. As we said before, for addition or subtraction, we have to have the same unit. So we can't add or subtract different units. So we can't do this. So can we convert one to another? No, because they are not units for the same quantity. Meter for length, kilogram meter over second, not for length. So we can't convert one to another by conversion factor. So in this case, we can't add or subtract different units. So it would be impossible to evaluate. But we can multiply or divide them easily. Here we're gonna talk about significant digit or significant numbers. First of all, we can ask, are there any difference between 2 kilograms, 2.0 kilogram, 2.00 kilograms? Are there any difference between them? We might say no, they all the same, 2 kilograms, 2 kilograms, 2 kilograms. But why we write it down in this way or in a different way? This is about the precision of the gauge or the scale we used to measure this mass. So if we used scales like this 1 kilogram, 2 kilogram, we write it down 2 kilogram. It might be 2.1, 2.2, 2.3, but we can't sure. So in this case, the tolerance here would be plus or minus 0.5. So if we have a scale, and this scale here what we measure, and here the 2 kilograms. In this case, we write down 2 kilogram, and we know it might be 2.1, 2.2, 2.3 till 2.5, or it might be 1.9, 1.8. So we have 2 kilograms and with tolerance plus or minus 0.5. If we used another scale like this one, and it give us 0, 2.0. In this case, it's 2 kilogram, but here we are sure it's not 2.1, it's not 2.2, it's not 1.9. No, it's 2 point. It may be 2.01 or 0.2 or 0.3. We are not sure, so we are saying that the tolerance in this case would be plus or minus 0.05. But we are sure it's not 2.1, not 1.9, not like here. In the third example here, it can be 2.00. It can't be 2.1, it can't be 2.01, it can't be 2.03. Maybe it can be 2.003 or 5 or whatever, but in this case, the tolerance would be 0.005. So although they are the same, 2 kilogram, 2 kilogram, 2 kilogram, but it can be like the tolerance or the precision of the scale we used to measure this thing. So it's different between 2 kilogram, 2.0 kilogram, or 2.00 kilogram. We are not going to focus about the precision in our course, but at least you know it. Units. Every physical quantity is measured by a unit. So if we have some length, we measure it by meter. It's a unit, or centimeter. It's a length unit. If we have something we want to measure its weight, we will measure it by kilogram, by tin, by libra. So it's a mass unit. If we want to measure a delay or a time, it would measure by hour, minute, second. It's also time units. There are two different kind of units. We have fundamentals or basic units and derived units. Fundamental units are 7 units. Derived units are derived from the fundamental. They came from the fundamental. For example, if we are talking about length, let's go, is measured by meter. What about area? Area, it's length time length. So it would be meter square. Meter square is meter times meter. So meter square is a derived unit. It's come from the basic unit or the fundamental unit, which is meter, and so on. The 7 fundamental or basic or primary units, fundamental unit, basic units, hours, length, meter, measured by meter, mass, measured by kilogram, time by second, temperature by Kelvin, electric current by ampere, amount of light by candle, amount of matter by mole. Those are 7, 1, 2, 3, 4, 5, 6, 7, 7 primary or fundamental units. We have 4 systems of units. We have the CGS units, FBS units, MKS units, SI unit or International System Unit. These systems, CGS or FBS, are indicating to the length, the mass, time unit, length, mass, time. Here, for example, in CGS, length by centimeter, mass by gram, time by second. In the FBS system, length by foot, mass by pound, time by second. In the MKS, length by meter, mass by kilogram, time by second. In the International System Unit, of course it's meter and kilogram and second. The important thing in SI system, SI International System Units, is using the prefixes. The prefixes like DC, centi, milli, micro, nano, pico, femto, hecto, kilo, mega, giga, tera, peta. For example, if we want to say 2, 3, 5, 4, 3, 0, 0, 0, 0, 0 meter. We won't write down it like that. We can use, then we can divide this by 1000 and we say this number with kilometer. It will be easy. Or we can eliminate another and we would say mega meter. Or we can say 2.3 giga meter. This is easy way to express numbers or values in international system units. Instead of using like inch, feet, or kilogram, ton, yard, and so on. Why this is easier than using feet and inch? For example, the feet. "12 inches. We don't know why it's 12, why it's not 15 or 10. The inch, 2.54 centimeter. So it's not easy number to memorize or to know. But in SI system, it's all about 10, and it replicates 10, 10 power 1, 10 power 2, 10 power 3, which is kilo, 10 power 6, mega, 10 power 9, giga, or 10 minus power minus 2, it's centi, like centimeter, centigram, centipoise, 10 power negative 3, millimeter, milligram, milli, whatever. Of course, these prefixes can be used with unit, mass units, length unit, force unit, and so on. So we can say centimeter, we can say centipoise, we can say centinewton, we can say micronewton, micrometer, microgram, and so on. So it can be used with any unit. Here are some rules for international system units. For examples, or what it matter here, we use a dash between two separate units instead of we can write Newton dash meter, Newton meter, instead of Newton meter or meter Newton, like this, because this can be confused with milli Newton. As we said before, in the prefixes we can use milli 10 power negative 3 millinewton. In this case it will be right millinewton or Newton meter. So to stay away from this confusion, we would put a dash between the two units like this. So it would be Newton dash meter or meter dash Newton. Plurals, we can say meter ms. So if it's 1 meter or 10 meters, 1 meter, 1 m, 10 meters, 10 m, not ms. Symbols derived from proper names like Newton, Watt, Pascal, Joule. The letter would be capital letter. So if we have 10 Joule or 10 Newton or 10 Watt or 10 Pascal, it would be capital letter. Anything else would be small letter. So the kilogram, the gram, the centigrade, or any other unit would be small, centimeter. But if we would write the whole unit like newtons, 90 Newton, in this case we would write it in a small letter, 90 Newton, not 90 Newton with a capital letter. If we have 90 Newton, if we would just write the letter N, it would be capital letter. But if we are going to write the whole unit, it would be 90 Newton with N small. And so on. Here are some units with proper names like ampere, A capital, Celsius, Fahrenheit, Joule. The most common units in our course would be the Joule, the Newton, the Kelvin, the Watt, and might be in the irrigation would be Pascal. I don't see Pascal. Pascal here. In the machine, you can use the same watt, of course. Here we usually use one letter, Newton just N, Kelvin just K, but sometimes we use two letters like Pascal, PA, to not confuse it with the boys. This is with P and this is with P, so here we used Pascal, two letters instead of just the B. We use two letters only when necessary to prevent them from being confused with other established units.